Hi Sunil, good evening. Priyanshu, Vishnuvardhan Reddy, good evening. Josna, good evening. Priyanshu, how many hour session is this? Jaya Singh, good evening. How are you all? How is the progress in physics? I hope you are doing fine. So, we were in the discussion of Khichdi of the three concepts: interference, diffraction, polarization, and last class, Jaya Singh, very good evening. Priyanshu, yeah. So last session we solved a few more problems, and today let us gear up for the additional problems. Previous contest. So let us see, and this is a question: if I naught is the intensity of the principal max, hi Josna, how are you? So I naught is the intensity of the principal max in single slit diffraction, then what will be the intensity when the slit width is doubled? That will be equal to 2 I naught as it is mentioned. Now goals of the day, we have to gear up for the problems, few more. Hi Vivek, good evening boss. So in the last session we discussed about a single slit diffraction followed by polarization followed by interference. Mansi, very good evening boss, how are you? Radhika, hello, how are you? Josna, hi sir, thank you for asking. Array, how I forgot you Josna, you are a bright student. Yeah, are you ready? Today whatever the problems I am giving, mind blowing problems, hair falling problems, body itching problems, 3 different categories today I am firing. So which model you want? Mind blowing or body itching or hair falling problem? I am waiting for you. Problems are of 3 types for entrance level: mind blowing, body itching, hair falling. When you think about the problem like showers of raindrops, hair will fall, it is called as a hair falling problem. Body itching, when you are reading a problem you don't get any idea, you will get irritation, called as a body itching problem. When you are reading a problem, really mind will become so hot, called as mind blowing problem. Oh, Vinayak want all mind blowing, body itching. Fantastic boss. Yeah. Problem number 1. To face each and every problem. Good. Vinayak is very eager. In YDSC, I naught is intensity. Radhika wanted mind blowing. First problem, very luckily you are getting mind blowing. In YDSC, I will see who will crack the mind blowing problems. Really they are great. I naught is the intensity at the central max. Beta is the fringe width. Then find intensity at a point P at a distance x from the center. This is the problem, your time starts. Once again, Akashdeep, very great boss. I naught is the intensity at the central max, beta being the fringe width. Then find intensity at a point P which is at a distance x from the center. This is the problem boss. Are you ready? I am giving. So how many of you have started the problem? Priyanshu, Sir, when geometrical optics will start? As per the schedule, boss, whatever the schedule they have, that will be as per that. So, shall we get for the problem? Priyanshu. So, C is the correct option. Fantastic, Priyanshu, fantastic. Fantastic, Priyanshu. C is the correct option. Now, let us see how this happens. When you observe this, it is mentioned that intensity at the center is maximum, as we all knew, and beta is the fringe width. First enter the data that is mentioned in the problem. Then find the intensity at a point at a distance x from the center. This is the center of the screen. This is the x. This is the point P. I want to know the intensity at this point P at a distance x. First, whatever they have asked, that is called as a tail. Let us move from the tail. As you observe that intensity I formula, I1 plus I2 plus 2 root I1 I2 cos phi. This is the problem. Here the intensity at the central max is mentioned. When they are not specifying the intensities individually, then you have to feel they are equal. Therefore, I max is equal to 4 times I naught, when I1 is equal to I2 is equal to I naught. When individual intensities are not given, you have to feel they are equal. So, if I max is equal to 4 I naught, that is equal to I1 is equal to I2 is equal to I naught. Now, here you have to find the phase difference phi. We know that phase difference delta x is equal to n lambda for constructive interference, and delta x is equal to 2n plus 1 into lambda by 2 for the destructive interference. Therefore, by looking at this problem, we know that sin theta is equal to tan theta is equal to x by d. This we know. Sin theta is equal to tan theta is equal to x by d. But for this sin theta, they have mentioned a maximum. So, n lambda is equal to x by d, and we need the phase difference phi. Phase difference phi will be equal to 2 pi x by beta. Then putting that in this equation, because how this 2 pi x by beta came, we know that phi is equal to 2 pi by lambda into delta x. So, get the value of delta x and put it in this equation, then you will get a phase difference phi is equal to 2 pi x by b. After that, come back to the first equation where I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. Substitute the value of cos phi, then you will come out with I dash is equal to I naught cos square pi x by beta. C is the correct option, boss. Fantastic. Now we are going to the problem number 2. A screen is placed 50 centimeters from a single slit which is illuminated with 6000 angstrom light. If distance between first minima and third minima in the diffraction pattern, that is a diffraction pattern, it is not difference pattern, it is a diffraction pattern, is given as 3 millimeter, find the width of the slit. Once again, screen is placed at a distance of 50 centimeters from a single slit which is illuminated with 6000 angstrom light. capital D is given 50 centimeter, lambda of the incident light is given 6000 angstroms. They mentioned the distance between the first and third minima in the diffraction pattern. First you have to write distance of the nth minima. Already we know distance of the nth minima n lambda capital D by small d, n lambda capital D by small d. So that is the distance of the nth minima. Now your time starts, you can finish the problem. Radhika, Akashdeep mentioned problem number 2, option is B, and Radhika mentioned option as A, and Mansi mentioned option as C. Still I am waiting few more options. Once again, capital D is given, lambda is given, and the difference of distance between first minima and third minima is given as 3 millimeter. Josna waiting for your answer. Josna said B. So still any more answers? Last 2 seconds more. I am waiting for few more answers. Vishnuvardhan Reddy garu, option B mentioned. Priyanshu, B option. Radhika mentioned A option. Bas, your time is up. Option B is the correct option. Option B is the correct option. Option B is the correct option. Fantastic, Josna. And who others mentioned option B? Fantastic, it is the option B. So for solving this problem, what is the source? Distance of the nth minima in a diffraction is given by n lambda d by small d. Apeksha, B. Fantastic. Priyanshu, C option. Sorry, it is option B. Now let us see. Distance of the first minima in the place of n, replace 1. Then what did you get? Lambda d by small d. Next, distance of the third minima y3. What did you get? 3 lambda capital D by small d. Then difference, it is given as 3 mm, y3 minus y1, 2 lambda d by small d is given as 3 mm. Then you are asked to find the width of the slit D is equal to 2 lambda capital D by 3 mm. Your answer should be 0.2 mm. Yeah, but anyway, one is given in cm, other is given in angstroms. So you keep everything in millimeter, because final answer is in millimeter. You should be very careful while doing the selection of system of units. So you should be very careful in deciding the unit. So in this problem, the topper who said the answer first, may I know? Priyanshu mentioned option B, and before Priyanshu, one more guy mentioned problem number 2, option B. So this is the way where we are coming out with the second problem. Now I am taking you to the third problem. Shall I move, or anyone has still any block in this problem? For minima in a diffraction, it is a maxima in interference. Vishnuvardhan Reddy garu. For minima in a diffraction, it is a maxima in interference. Whatever you are saying, n plus 1 by 2 into n lambda, that is related to the interference, because in this problem it is single slit. For interference you don't have single slit. There you had 2 slits. Got it? Yes, Shall I get it for the next one? Third problem. The two current sources of equal intensity produces maximum intensity of 100 units at a point. If the intensity at a point, that is over, continuation, if the intensity of one of the sources is decreased by 36% by reducing the width, then the intensity of the light at the same point will be how much? The intensity of the light at the same point will be how much? Once again, the two coherent sources of equal intensity, I1 is equal to I2 is equal to same, maximum intensity of 100 units, maximum intensity formula just now in the previous very beginning problem I had given. So, maximum intensity of 100 units at some point P. If the intensity of the one, after some time what I did, if the intensity of the one of the source I reduced by 36% just by reducing the width, then the intensity of the light at the same point, your time starts. Apeksha came with D, Akash Deep came with D, Josna came with D, and Mansi came with D. So everyone is D. Still I am waiting for few more answers. Where is Radhika? Where is Vivek? Vishnu Pratap Singh? I am waiting for you all. Mansi came with the D option. Others, Priyanshu, where are you? Vishnuvardhan Reddy, where are you? What is the reply? Vishnuvardhan Reddy also mentioned it is a D. Still, Vivek Pratap Singh, what is your answer? Our time is up. Now, the correct answer is equal to 81. Fantastic. Everyone has made it very clearly as 81. See, two coherent sources of equal intensity that is given. One is I1, other is I2, they are equal and let it be equal to I0. From the problem, this is the first information you are supposed to get. They mentioned maximum intensity as 100 units. Maximum intensity will be obtained when phase difference is equal to 0, 2 pi, 4 pi, dot 2n pi or nothing but n lambda. In such a case, I maximum is given as 100. But I maximum in terms of the individual intensities, for Vinayak Singh I am teaching, you are saying it is, problem is unclear, I am saying for you. I maximum is equal to 100 given. I maximum in terms of I0, 4 I0 is given as 100. From this, individual intensities is equal to 25 units. This is before decreasing. Vinayak Singh, this is before decreasing. So, in this, I1 is equal to 25, I2 is equal to 25, because both are equal. Now, he reduced I1 by 36%, means decrease in intensity delta I, 36 by 100 into original intensity, that is equal to 9. Decrease 36% of 25 is equal to 9. Then what is the new intensity of I1? I1 dash, that is equal to 25 minus 9, that is equal to 16. Now, I1 dash is equal to 16 and I2 is already unchanged 25. Then you have to find the resultant intensity, that is nothing but root I1 plus I2 plus 2 root I1 I2 cos phi. Then the resultant intensity I net in the second case will be 81. I1 plus I2 plus 2 root I1 I2 cos phi. Then you will get the value 81. Got the clarity, Vinayak? I have given step to step for your easy understanding. Is it okay for you? You got the clarity? Friends, shall we proceed to the next problem? Any doubt anyone has in the first band of 3 problems? So, in the first band of 3 problems, in this problem first came with Apeksha D, followed by Akashdeep, followed by Josna, followed by Mansi, followed by Vishnuvardhan. So, this is the logic behind this problem number 3. Riddhi, what happened? Riddhi, any doubt? You mentioned no. May I know why no? You want me to recap once again this problem? Yeah. I am proceeding to the problem number 4. See the problem. In YDSC, fringes are displaced by a distance x when a glass plate of refractive index mu 3/2 is introduced into the path of the beam. When this is replaced by another of same thickness, another glass, another material, but thickness is maintained the same, then shift of the fringes will be equal to 3/2x. Then refractive index, this is mu1. Mu1 is equal to 3/2. Refractive index mu2 of the second plate is equal to how much? Once again, in YDSC, fringes are displaced by a distance x when a glass plate of refractive index mu1 is equal to 3/2 is introduced in the path of the beam. When this film or this glass plate is replaced by another one of the same thickness, then shift of the fringes is equal to 3/2x. Then what is the refractive index of the second plate? Your time starts. This time I will see who will be the first. Now today mixed people are coming, very nice. Everyone is participating in the game. Really I am very enterprised with your performance. So everyone is neck to neck doing the problems. Everyone wants to show their supremacy and confidence levels. This is the spirit I wanted from you all. Keep this spirit alive till the final entrance examination. Then you will be within either top 100 or top 1000 in all India. Apeksha came, Mansi came with third option, Apeksha came with option B. Still I am waiting for few more options. Vishnuvardhan Reddy came with the option A. Josna came with the option A. Are very good. Different options, different psychologies, different analysis, different analytical skills. Let us see finally who will be the winner for this problem. C came, B came, A came. Josna came out with the option A. Today Josna is very aggressive in the game. Very aggressive Josna today. She want to push everybody back and she want to be at the front lines portion of the problems. Adina Vishnuvardhan Reddy is mentioning some formula on the board. Akashdeep came with option A. Yes, your time is up. The best option is 1.75. Josna and Vishnuvardhan Reddy, Akashdeep perfectly analyzed the problem. Initially, I taught you this concept, shift in fringe, when a film is placed in front of a slit, then what happens, you know, some of the fringes, central bright will be shifted towards that slit in which the film is introduced. So, for this, the shift will be given by mu minus 1 into T fringe shift formula is this. Waxing also came, fantastic, A. Now, initially for the first one, this is given as, this is first step. Second step, x is equal to mu 1 minus 1 into thickness T beta by lambda, that x is x only. In the second case, when Josna and Reddy are really, today they are locking their horns, they are fighting like anything today. And in the second case, 3 by 2x is equal to mu 2 minus 1 into T into beta by lambda. After the third step, you have to go for simple algebra, dividing second step by third step, then you will come out with 2 by 3 is equal to 2 by 3 is equal to mu 1 minus 1 by mu 2 minus 1. Now you can easily crack mu 2. Yeah, new star Adina Vishnuvardhan Reddy has entered the game. Josna today is very aggressive. Maybe Josna came with Kellogg's and milk. She is showing very ferociously on the problems. Yeah, Josna, great. Where is Radhika? And where is Vinay Pratap Singh? Where are you all? Please participate in the game. So, now I am proceeding to the problem number 5. Shall I? I hope all the 4 problems, everyone is sound enough. Everyone is sound enough. Mansi, where are you? Deepak, where are you? Please come onto the screen, play the game. It's not subject, it's not physics, it is a game, reality show, that like. Now I am proceeding to the next one. A circular current loop of magnetic moment M is an arbitrary orientation. External magnetic field B. The work done to rotate the loop by 90 degrees about the axis perpendicular to its plane. So, in this, what was your answer? And who will be the winner? You will get the information soon. Just let us go to the next one. Now it is the time of contest question. See, in the figure, this is a very beautiful problem and you are supposed to really solve this problem. Yeah, the winner of the previous contest, Mansi, the winner is Mansi. Congratulations, Mansi. Very great. Now only I am asking about you. So you came in the shape of a winner. Keep it up. You will get one atom section free. Good, good. Now, this is a contest time and really this is a very sound problem. Really, who will win this contest question? Real genuine winner. Tomorrow I will see in the next session who will be the winner of this contest time. In the figure, S1 and S2 are in the figure S1 and S are the sources that emit a light of lambda. The sources are exactly in phase and separated by a distance of 1.5 lambda. Separated by a distance of 1.5 lambda. If we start at the indicated start point and travel along the path 1 and 2, the interference produces maxima all along which path? Path 1, path 2, any path? None. This is a very good question, you can attack. Now we are into the second band of problems for today. This problem, two sources are separated by a distance small d, are radiating the light in phase having a wavelength of lambda. A detector moves in a big circle around the two sources in the plane of the two sources. Then the angular position of n is equal to 4, interference maxima. This is the problem, and in this the options given. Number 1 option, sin inverse n lambda by d. Number 2, cos inverse 4 lambda by d. Number 3, tan inverse d by 4 lambda. And number 4, cos inverse lambda by 4d. This is IISR problem. Adhina Vishnuvardhan Reddy declared the answer as B. And this problem once again, two sources separated by a distance d are radiating in phase having lambda. A detector moves in a big circle around the two sources in the plane of two sources. Then the angular position of n is equal to 4, interference maxima is equal to how much? Vishnuvardhan Reddy declared as B, and Radhika also declared as B, Mansi declared as B, Josna also declared as B. Still anybody, any other answers? I think everyone is fond of B, but think in multiple dimensions for solving this problem. Think in multiple directions for solving this problem. Mansi B and Pratap Singh, where is your answer? Radhika, where is your answer? Already Radhika has declared her answer very beginning immediately. In the previous question, answer was D. Contest time. Now, your time is up. The angular position of n is equal to 4, interference maxima is Akashdeep said it as D, Vinayak Singh said it as D, and 4 members said it as B. Now the final answer is option B. Fantastic. Vishnuvardhan Reddy, Radhika, Josna, you have given. Mansi, the answer is cos inverse 4 lambda by d. See, let us take an arbitrary point P. So this is a light moving from S1, this is a light moving from S2 onto P, then this length is nothing but path difference delta x. So in this case, let us see the solution. Delta x is equal to d cos theta. D is nothing but the distance between the two slits. But for maxima, delta x is equal to n lambda. n lambda is equal to d cos theta, but they have mentioned n as 4. So 4 lambda is equal to d cos theta. Therefore, cos theta is equal to 4 lambda by d. Finally, theta is equal to cos inverse 4 lambda by d. Fantastic, really very good. Radhika again came into the game to beat Pratap Reddy. Yeah, I mean our Vishnuvardhan Reddy. So Vinayak Singh, how come? Vinayak, for you only again I have written step to step. Vinayak, for you only I have written again step to step. Delta x is equal to d cos theta in this case, because this angle is equal to theta. Then delta x is equal to adjacent side by this distance d. Vinayak, if you say green signal, then I will proceed, otherwise once again I will explain. I have given the geometry of the given figure. For constructive interference, delta x path difference is equal to n lambda. From the geometry of the given figure, that delta x is equal to d cos theta, n lambda is equal to d cos theta. They have asked angular position means theta corresponding to the number n is equal to 4. So 4 lambda is equal to d cos theta. So cos theta is equal to 4 lambda by d. Theta is equal to cos inverse 4 lambda by d. I hope now you got it. Very good. Really I am very much happy. Today Vinayak is asking doubts. Asking doubts implies he is working on the theory, he is working on the concepts. Really fantastic. Now it is the time of problem number 6, body itching problem. Two sources S1 as well as S2 are at a distance of 4 lambda. This time I will see who will be the winner for this problem. These are all very high end problems. Two sources S1 comma S2 are at a distance of 4 lambda. Sources are along y axis, whereas detector moves along x axis leaving the origin, and at far off points the number of points where maxima are observed is. The number of points where maxima are observed is. This is a question. Thank you sir, and you always catch exact. Very good Vinayak. Your compliment is motivation to me. Teachers also needs motivation like students. So you are all really motivating me. Fantastic. I am very lucky to have a batch of dynamites like you. So problem number 6. Two sources S1 and S2 are at a distance of 4 lambda. Sources are along y axis, whereas detector moves along x axis leaving the origin, and at far off points the number of points where maxima are observed is. Shreyans came with A, Apeksha with third option, Akash Deep with B, Vishnuvardhan Reddy with option A, and Vinayak Singh with option B, and Josna with option A, and Mansi with option A. Very, very nice. Really, you are all playing the game, boss. This is the way how I expect you. Still, I need few more options before you crack the right answer. Once again, work it on the problem. These are the high-end problems. Don't immediately say this option, that option. Work with base level concepts and bring base level concepts into action and crack the problem. S1 and S2 are at a distance of 4 lambda. Sources are along y axis, whereas the detector moves along x axis leaving the origin, and at far off points the number of points where maxima are observed is. So your time is up. Mansi came with option A, and Josna came with option C, and Akash Deep came with option B. Vinayak Singh came with option B. So the joint winners of this problem are Akash, Deep and Vinayak Singh. Fantastic. Option B is correct option. The number of points where maxima are observed is equal to 3. Now let us see the solution for the problem. First, to create the coordinate system, x-axis, y-axis, and they mentioned sources are along the y-axis. So I take one source S1, other source S2, and they mentioned that the gap between S1 and S2 is equal to 4 lambda. Yeah, Apeksha, you are the person who gave first answer, boss. Really, I have to appreciate you. You are the person who gave the first answer. I saw it, just the letter has gone up. So it was Apeksha who declared the answer to the world first. Great Apeksha, fantastic. So this is the geometry of the figure. Sorry, I did not say your name, but you are in my mind. So this is the geometry, and they mentioned that sources distance is 4 lambda and they are along y-axis, whereas the detector is moving along x-axis, leaving at the origin. Now this is the geometry. Now this is S1, this is S2. Now at the point D, these are the waves coming from S1 and these are the waves coming from S2. So this is a path difference. Always for showing the path difference, you have to draw the line from the source which is traveling lesser length. This is P. Say for example, this is the distance of the point of observation from the detector, xn. S1P, S2P, this is the final geometry. So when you observe the Pythagoras theorem, hypotenuse square S1D square is equal to S1 S2 square plus S2D square. But S1D is nothing but S1P plus PD. So I write S1D as S1P plus PD whole square is equal to S1 S2 whole square plus S2D square. But S1P indicates the path difference. So S1P is equal to path difference delta x. But for maxima they asked path difference delta x is equal to n lambda. So in the place of S1P replace with n lambda, and P is nothing but the distance of the point of observation from the detector, xn whole square is equal to S1 S2. They already mentioned S1 S2 is equal to 4 lambda whole square plus S2D. If that angle theta is very small, then we can approximate xn and S2D are barabar. This can also be taken as xn when that angle is very small. So this can also be taken as xn square. When you solve this equation, then step number 4, n lambda plus xn. When you solve this xn, you will come out with 16 lambda square minus n square lambda square divided by 2n lambda. Now for the first point, n is equal to 1, then the distance of the first maxima 7.5 lambda, n is equal to 2, x2 is equal to 3 lambda. Next, n is equal to 3, x3 is equal to 7 by 6 lambda. Next, n is equal to 4, then you will come out with x4 is equal to 0. So how many maxima are possible? x1, x2 as well as x3. Therefore, number of maxima is equal to x1, x2, x3, that is 3. This is the solution. Entire solution is on the board. If anyone has a doubt in any step, I am giving you very point to point for easy understanding, like peeling the fruit and putting that fruit into the mouth. So if you are stuck up at any of the given points, please respond. So this is a very good problem, and these are all higher end problems. So every problem try to analyze with the skills, but at NEET level these many tough problems are not given, but for JEE level, advanced level, you have to be very shrewd with these type of models. So any doubt, if you don't have any doubt, mention no, then I will proceed for the next problem. Clear, very good Vishnuvardhan. A new hero in the form of Vishnuvardhan has entered the game. Clear, fantastic. Just now I am proceeding, boss. Next problem. This is another problem which is really very belonging to the any one of the three categories. A beam of natural light falls on a system of 6 Polaroids. Not only single Polaroid, it is falling on 6 Polaroids which are arranged in succession, that each Polaroid is rotated by 30 degrees with respect to the other one, previous one. Then percentage of incident intensity that passes through the system is equal to how much? C. First option 100, second option 50, third option 30, fourth option 12. I will see who will give the fastest, quickest reply. Yeah, Akashdeep has declared already option D. Still I am waiting for few more options. Akashdeep came with his option as a D. Mansi came with C option. Wow, fantastic. Still other players, I am waiting for you here. Your mentor is waiting for you. Akashdeep D, Mansi C, Radhika came with option D. Very good. Still Adina Vishnuvardhan came this time bit late, D. Vinayak Singh came with option C. Still I am waiting for others. Mansi, where are you? Already she has given as C. Very good. Josna declared as a D. Shreyans given as a D. Apeksha given as a D. Apeksha given as D. Fantastic, your time is up. The correct option is option D, 12%. Akashdeep was the person who declared the answer first among all of you. Really great, Akash. Keep it up, my dear boyfriend. So it is 6 Polaroids are there. So first one is nothing but it will convert total intensity into half of that intensity. So I is equal to intensity from all the 5 Polaroids remaining, I naught by 2. I naught is the initial intensity, cos square 30. Each is differed with the previous one by 30 degrees to the power 5. That is step number 1. I by I naught. Find it. Step number 3. I by I naught into 100. That is the question they have asked. So I is equal to I naught by 2 cos square 30 to the power 5. Then I by I naught is equal to cos square 30 to the power 5 by 2. That is nothing but root 3 by 2 whole square 1 by 2 to the power 5. That is nothing but root 3 by 2 to the power 5. This is nothing but 3 by 4 to the power 5 to the power 1 by 2. Then you can finish the problem. You will come out with 12%. Now, a beam of plane polarizer light falls on a polarizer of cross-sectional area 3 into 10 to the power of 4 minus 4 meters square. This is another very interesting problem. Flux of energy of incident ray is equal to 10 power minus 3 watt. Angular frequency of rotating polarizer is 31.4 radian per second. Then energy of the light passing through the polarizer per revolution is. Note down this problem and we will discuss this problem in the next section. Very good. Thank you for joining. I have given the best number of problems, a set of 11 problems I had given. Try to solve them and thank you for joining with us. Have a good day and continue this practice, and in the next session you will come out with the best performance. Have a nice day. Thank you.